السلام عليكم. في هالمحاضرة رح نتطرق للنيوكليك أسيد إن شاء الله. النيوكليك أسيد مثل ما اتطرقنا بالمحاضرة السابقة على البروتين وعرفنا الكومبوزيشن ستركتشر والبروتين. هاي المحاضرة إن شاء الله نتطرق للنيوكليك أسيد and composition of the nucleic acid, their structure and function. Nucleic acid are molecules that store information for cellular growth and reproduction. السلام عليكم. في هالمحاضرة إن شاء الله رح نتطرق للنيوكليك أسيد. إحنا بالمحاضرة السابقة تكلمنا عن البروتين structure والبروتين function and type. السلام عليكم. في المحاضرة السابقة تكلمنا عن البروتين composition structure and function of the protein. هاي المحاضرة راح نحاول نتطرق للنيوكليك أسيد وأيضا نتعرف على structure of the nucleic acid and function. Nucleic acid are molecules that store information for cellular growth and reproduction. There are two types of nucleic acid: deoxyribonucleic acid (DNA) and ribonucleic acid (RNA). These are polymers consisting of long chains of monomers called nucleotides. A nucleotide consists of a nitrogenous base, pentose sugar, and phosphate group. إذا النيوكليوتايد nucleic acid هو عبارة عن long polymer of long chain of nucleotide. The nucleotide consists of nitrogenous base, pentose sugar, and phosphate group. احنا بالمحاضرة السابقة تكلمنا عن البروتين وعرفنا البروتين هو أيضا عبارة عن the sequence of amino acid bind together by peptide form. While the nucleic acid, it is a polymer of nucleotide. Nucleotide, it is the building unit of the nucleic acid. Nucleotide consists of three components اللي هو nitrogenous base, pentose sugar, and phosphate group. Again, nucleic acid include DNA and RNA are a nucleic acid, which are long thread-like polymers made of a linear array of monomers called nucleotides. All nucleotides contain three components. First, a nitrogen heterocyclic base. Second, a pentose sugar. Third, a phosphate residue. As we see in this slide, the pentose sugar, the sugar الخماسي, appear in the middle and attached to the nitrogen base at the level of carbon atom number 1, while at the level of carbon atom number 5, the phosphate group will be attached to it, while the carbon atom number 3 will be attached to the phosphate residue of the adjacent nucleotide. In the carbon number 2, the OH group, presence of the OH group, disappears in the RNA, while in the DNA, the oxygen atom will be removed, and this is why it is called DNA, which is mean deoxyribonucleic acid, which is mean removal of oxygen atom from it. This is another picture for the arrangement of the nucleotide, in which the ribose sugar in the middle and attached to the Y2 end to the phosphate group and other end to the nitrogenous base, and the nitrogenous base of two types, either purine or pyrimidine type. The pyrimidine nitrogenous base consists of cytosine, the abbreviation C, which is present in the DNA and RNA, and thymine, abbreviation by T. Also, it is present only in the DNA, and uracil U, which is present only in the RNA. So, the pyrimidine nitrogen base consists of cytosine, present both in DNA and RNA, while thymine present in the DNA and uracil present in the RNA only. while the purine consists of adenine and guanine, which are both present in the DNA and RNA. So the nitrogen present in the RNA will be nucleic adenine, guanine, cytosine, and uracil. When they be added to the ribose sugar or pentose sugar, it will become the nucleoside and will become adenosine, guanosine, cytidine, and uridine. By addition of the phosphate residue or phosphate group, the whole three components of the nucleotide will be complete, and this is we call it nucleotides. These like adenosine 5 monophosphate, guanosine 5 monophosphate, and cytidine 5 monophosphate, uridine 5 monophosphate. And as we said, 5 monophosphate, these refer to the attachment of the phosphate group to the sugar at the level of the carbon number 5. While the nitrogen base in the DNA will be include adenine, guanine, cytosine, thymine, and when be added to the sugar will be deoxyadenosine, deoxyguanosine, deoxycytidine, and deoxythymidine, which are these are referred to the nucleosides, and the whole nucleotide will be deoxyadenosine 5 monophosphate and deoxyguanosine 5 monophosphate and deoxycytidine 5 monophosphate or deoxythymidine 5 monophosphate. Structure of the nucleic acid. Nucleic acid structure is often divided into 4 different levels. And as we mentioned in the protein and mentioned the protein structure, we also divided it to the 4 levels: the primary, secondary, tertiary, and the quaternary structure. Same thing for the nucleic acid will be divided into 4 levels: primary structure, secondary structure, tertiary structure, and quaternary structure. Primary structure consists of a linear sequence of nucleotides that are linked together by phosphodiester bond. The primary structure consists of a linear sequences of nucleotides binding together by the phosphate group. In secondary structure, this is the set of interaction between bases. In DNA, double helix, the 2 strands of DNA are held together by hydrogen bond. The nucleotides on one strand base pair with the nucleotide on the other strand. The secondary structure is responsible for the shape that the nucleic acid assumes. In the primary structure, the attachment occurs through the sugar with the phosphate group in linear chain, while in the secondary structure there is 2 strands and the binding between the nitrogen base of the one strand with the nitrogen base of the other strand by the hydrogen bond. In tertiary structure, this is the location of atoms in the 3-dimensional space, taking into consideration geometrical and steric concentrate, a higher order than the secondary structure, in which a larger scaffolding and a linear polymer occur, and the entire chain is folded into a specific 3-dimensional shape. In the tertiary structure, there is folded occur in each strand and involve both 2 strands, give the 3-dimensional structure or give the 3-dimensional shape of the nucleic acid. In the quaternary structure, this is similar to that of the protein quaternary structure, although some of the concepts are not exactly the same. Quaternary structure refers to the higher level of organization of a nucleic acid. Moreover, it refers to the interaction of the nucleic acid with the other molecule. This is the organization in quaternary structure. It is more complex and more than in the protein, and it is referred to the binding of the nucleic acid with the other molecule. structure and function. RNA is the nucleus and cytoplasm. RNA has a linear single sequence of a nucleotide containing the sugar ribose and protein base include adenine, uracil, cytosine, and guanine with backbone of the sugar phosphate. This is the structure of the RNA in which a single sequence molecule and backbone of the RNA consists of alternating of phosphate and sugar, alternating of the phosphate and sugar. Types of RNA include prokaryotic and eukaryotic organisms. Three main classes of RNA molecules exist. First, messenger RNA, aggregation of mRNA, and second, transfer RNA with tRNA, and third, ribosomal RNA. This is the main three major classes of the RNA. There is another small percentage of the RNA, including small nuclear RNA, microRNA, small interfering RNA, and heterogeneous nuclear RNA. Transfer RNA are the smallest of the three major species of the RNA molecule. They have 74 to 95 nucleotide residues. They are synthesized by molecular processing of the precursor molecule. They transfer the amino acid from cytoplasm to the protein synthesis machinery. This is the main transfer RNA. They are easily soluble. This is called soluble RNA. And they are also called adapter molecules since they are act as adapter for the translation of the sequence of nucleotides of the messenger RNA into specific amino acid. There are at least 20 species of the transfer RNA, one corresponding to each of the 20 amino acids required for the protein synthesis. Transfer RNA are the smallest of the three major RNA. It is responsible for the translation of the sequence of the nucleotide to the corresponding of the amino acid, which then transfer to the protein synthesis machine, which is in the ribosome. Ribosomal RNA, the function of the ribosomal RNA molecule and the ribosomal particle are not fully understood, but they are necessary for ribosomal assembly and seem to play a key role in the binding of the messenger RNA to ribosome and its translation. Recent studies suggest that the ribosomal RNA component perform the peptidal transferase activity and thus is an enzyme ribosome. Small RNA, most of these molecules are complex to the protein to form ribonucleic protein and distributed in the nucleus and the cytoplasm or endocyte. They range in size from 20 to 300 nucleotides and are present in 100,000 to 1 million copies per cell. Types of RNA. This table illustrates the type of RNA where they synthetic and function. First, ribosomal RNA. It's about 75% of the whole total RNA. Their function is major component of the ribosome. Second, messenger RNA is about 5 to 10% of the total RNA, carry information for protein synthesis from the DNA in the nucleus to the ribosomes. And transfer RNA represent 10 to 15%, which bring amino acid to the ribosomes for protein synthesis. DNA structure and function. Complementary base pairing of the nucleotide with hydrogen bond, that means purine always combined with pyrromidine, and these matching nitrogen bases are referred to as complementary bases. For example, adenine of the one sequence is always hydrogen bond to the thymine on the other, while guanine is always paired with the cytosine and alpha. This is DNA structure is important in which there is a complementary base pairing of the nucleotide, in which each nitrogen base will be paired with the corresponding nitrogen base on the other sequence. This is the backbone of sugar phosphate of the secondary structure of the DNA, in which there is a complementary base pairing between one strand in the nitrogen base of the one strand with the nitrogen base of the other strand. This is the phosphate structure of the DNA, in which the folding and the three-dimensional structure of the molecule, and the same binding of the hydrogen bond between the complementary base pairing with the two strands. Function of the DNA: to store genetic information, maintain growth and repair, control all cellular activities, contains protein codes, ensure each daughter cell and gamete receives exact genetic information. This table illustrates the comparison between the DNA and RNA. First is the structure. DNA contains double helix or alpha-helix structure, while the RNA has many or single structure. The strand in the DNA are 2, while in the RNA 1. Sugar usually deoxyribose in the DNA, while it is ribose in the RNA. Location in the cell: DNA located in the nucleus and mitochondria, while the RNA located in cytoplasm and the nucleus. Function: the function as mentioned for the DNA is store genetic information, maintain growth repair, control all cellular activities, contain protein codes, and ensure each daughter cells and gamete receive exact genetic information. While for the RNA, it has the protein synthesis by messenger RNA and transfer RNA, and ribosomal RNA.